Have you ever really stopped to think about what holds our modern world together? It's not just the roads and bridges we can see. It's this huge, incredibly powerful, and, well, mostly invisible system of technology. So in this explainer, we're going to peel back the layers of that invisible architecture and find out what really makes our world tick.
So, what is this system? Well, it's called Information and Communication Technology, or just ICT for short. And it's pretty much the silent force behind everything we do, from launching rockets into space all the way down to the smartphone that's probably in your pocket right now.
I mean, this stuff is the bedrock of our global economy, of our social lives, but how does it all actually work? That's the big question, right? And that's exactly what we're going to get into as we pull back the curtain on this incredible system.
All right, so first up, let's just try to wrap our heads around the sheer scale of its impact. Because, see, ICT isn't just one thing. It's a revolutionary force that has completely remade pretty much every single part of our society.
Think about healthcare, for example. ICT is what lets doctors consult with patients who are hundreds of miles away through telemedicine, and it powers the unbelievably precise equipment they use in modern surgery. It's amazing.
And business? Whoa, it's been totally transformed. A small shop in your town can now become a global marketplace, connecting sellers with buyers in an instant, 24/7, from literally anywhere on the planet.
And then, of course, there's our own lives. This tech is woven into the very fabric of our day. Every movie you stream, every song you listen to, every single post you share, yep, it's all being powered by this invisible web.
ICT even lets us push the absolute boundaries of what's possible in science. It gives us highly specialized tools like cryosurgery, where technology gives doctors a level of control that was, not too long ago, pure science fiction.
So we can see what it does. But that just brings us right back to our big question. How? Well, it all starts with the very first, most fundamental layer, the network that connects everything together. At its heart, a computer network is really just a way for devices to talk to each other. The best way to think about it is like a massive global system of digital roads, allowing information to travel from any one point to any other point. And this is what's so wild, the incredible range of scale. On one hand, you've got a personal area network, or a PAN, which might just connect your phone to your wireless earbuds. But on the other hand, you have a wide area network, or a WAN, which forms the very backbone of the global internet, connecting entire continents.
And these networks aren't just some random mess of connections. They're actually designed very carefully in different layouts, or topologies, and each one is for a specific purpose. Whether it's a simple bus line, a centralized star, a continuous ring, or an ultra-reliable mesh where everything is connected to everything else.
Okay, so we've got all these connected computers, but how do they actually represent and understand information? To get that, we need to learn their secret language.
The world we experience is analog. It's smooth, it's continuous, kind of like a sound wave or a dimmer switch for a light. But computers, they're digital. They see the world in separate, distinct steps. Think of it like a simple light switch. It's either on or it's off. There's nothing in between. And here's the magic trick. Computers use that simple on or off state to count. We call it binary. Off is a 0 and on is a 1. And with just those two numbers, believe it or not, computers can represent every single letter, every color, and every sound you've ever heard online.
And how do they process all that information? Well, they use millions of tiny electronic switches called logic gates. By combining these simple on-off signals with really basic rules, like and, or, and not, computers can perform unbelievably complex calculations and make decisions in the blink of an eye.
Okay, so we have the networks and we have the secret language. Now, let's finally connect the dots and see how these invisible pieces come together to build the actual digital world we use every single day.
So, meet HTML. This is the structural language of the entire web. Think of it as the blueprint for every web page you've ever visited. And it's built right on top of that foundation of information and communication we've been talking about. See this code here? It might look pretty simple, but it is incredibly powerful. This human-readable language tells your web browser exactly how to take all that underlying binary data, all those ones and zeros, and organize it into the headlines, the paragraphs, and the images that make up the websites we know and use. And there you have it. We've kind of journeyed from the vast global network of underwater cables down to the simple on or off language of binary code, and then all the way back up to the rich interactive apps we use constantly.
Each layer just builds right on top of the last. So now that we understand the foundations, we can start to look ahead, because these same principles aren't just running our world today, they are actively building the world of tomorrow. Artificial intelligence, for instance, is really a direct evolution of ICT. It's all about using those massive networks and incredible processing power to teach machines how to learn and reason from just staggering amounts of information.
And then robotics takes it all a step further. It combines the information processing of AI with the communication ability of networks to give that digital intelligence a physical body, a machine that can actually go out and interact with the real world.
And finally, we're seeing technologies like biometrics, where ICT is becoming deeply personal. Here, our own unique human traits, like our fingerprint or our face, are becoming the key, the very interface between our physical selves and our digital lives.
So from invisible networks to intelligent machines, this architecture is constantly evolving. It's growing more powerful and more integrated into our lives every day. And that leaves us with one final, really crucial question to think about. As we build this future, what are the new rules and responsibilities we need to create to guide it wisely?